Okay, this is going to be a solution to the quarterfinals of the Excel World Championship. This is Vlookie Teur. We have all these kind of tunnels, pipes, and some kind of materials, and we move through this pipe maze here to collect the materials. Actually, quite a hard case. Didn't do very well the first time I tried it. Figured it out on a second solve, a little bit messy, and then have somewhat of a clean solution now. On the day, some people got this level 7, which was like navigating the full maze live within the 30 minutes. Very curious to see how they did that, because maybe there's a simpler way than me, but I don't know. Anyway, let's get to it. So bonuses, how many resources are in the mine? They're only on row 103 in column CX. So if I just zoom out a bit, you've got column CX here and the row down here. So I can just highlight both of those. I can see we have 121 things, but our columns and rows are labeled. So 121 minus 2 is 119. And then all the bonuses are quite hard. We'll leave them till the end. So first question, add up the value of all of these resources. So that's going to be the sum of X lookup all of this stuff in our resources and give us the value. Nice easy question 1. Okay, level 2, I'm going to set a lot of this up now. So we want to get the kind of points out, so it's quite easy to do, but if I set the rest up now, the later levels will be easier. So I'm going to set this up just like the old pipe mare case. I've got a video on that. I'd recommend watching that if you haven't already to understand what's going on here, where we have like a connection to and connection from, and then you can basically check where the zeros overlap and it means you are connected. So let's just text split this down by colon. We know this is going to stay the same, this is going to stay the same for kind of the from and to. And then this one, all these corner ones are going to be completely opposite. So to get the opposite from zeros and ones, you just do 1 minus. So if I do 1 minus that, I'll get the opposites. And these T-shaped pipes, I want to keep the top and bottom in these ones, but swap the left and right. So let's just copy these as values. So let's swap the left and right here. And then again, swap the left and right. And for this one, the left and right stay the same, but the top and bottom switch. So tops and bottom switches, tops and bottom switch. And then this obviously can go in and out from either direction. I'm going to say concat all of these 4. So that's kind of my connections from. And that's not dynamic anymore because I copied its values, so let's just do that. Okay, so that's our froms. So let's just put those in here, delete this stuff out. And then my 2s I want to get like without these delimiters in. So let's substitute out those for blank. This is my from, and it should be good to go. So I'm going to call this 2, I'll call this from. So I'm going to name range this, so let's call that pipe. I don't actually need this name bit here, so I think I'll just delete it. And then Control Shift F3 and just label the tops. Now for question 2, I can say X lookup all the pipes in our pipe and give me connections 2. That's going to give me all the 1s and 0s for them, so I'm going to concatenate them. So let's show you what that looks like. So all the 1s and 0s, and I basically just want to count the occurrences of 1 in that string. So how many 1s are there? How many connections out of the pipes are there? Okay, question 3. We want to check if the pipes connect to each other horizontally. So let's start to do this in a model. Okay, so let's to-call all of this. And we basically want to check if they connect left to right. So the order of this is top, left, bottom, right. I'm just going to write it up here somewhere to remind me. Top, left, bottom, right. So right is going to be the 4th digit when I pull things out. So let's say X look up the pipe in pipe and give me 2. And I spelled pipe wrong, so let's make sure we spell that correctly. And then I want to look up the from as well. So let's drag this down here. So we basically want to check like if the first pipe connects to the second and so on and so on. So to check if they connect, we kind of want to do the right of each of those. So let's say right of that times right of that. So that's going to give us kind of a 1 or a 0 where they connect. So we can just do the sum of all of that stuff. So that's a little bit confusing, but it makes more sense if you've done the other pipemare case. Okay, level 4, we're given a starting direction. We're going to keep traveling until we bump into a wall, i.e. there's no connection to a pipe. So let's set this one up, example 4, and we'll do a model that will carry over to kind of question 6 here. So let's list out everything we need. So address, arrow in cell, or let's call it contents, and the address is going to be this, our arrow is going to be this, our contents is going to be, let's label our map first, so let's go to this whole game board. It's going to be from there all the way down to there. Let's label that map MP. So we can say address to contents of this in our map, so that's our pipe 2. Now let's figure out our address we go to. So I'm going to actually turn this into an RC reference, so RC ref converter, and our cell 2 is going to be this plus RC converter of the arrow, so that's just turning it into RC coordinates again. That's where I want to go to, and then contents 2 is address to contents of this in our map. And then we can look up that pipe like we did there, look up the second pipe there. Now to check if they connect, we need to kind of pull out the digit from this direction. So top, left, bottom, right, that's the order of the arrows. And then let's just grab our arrows and line them up. So bottom, top, right, left. This is actually quite a long case, I feel, which explains why no one scored all of the points. So let's delete this stuff for a sec. So to check if they connect, I basically want to say X match this arrow on here. So I'm looking for the third, is it the third? Fourth digit from these things. So I can say mid of these and the fourth position. And I want one digit. So what that will give me is the 2 digits from the right, and then I can just product. So product of those. So that is connected or not connected. Let's get rid of this highlighting for now. Okay, now we can see that these should be connected. I'm actually getting a 0 because mid is taking text, so I need to convert to numbers. So now it says they're connected. So I'm going to say if connected, then do where we go to, otherwise be stuck at where we came from. And then all of this stuff should be able to be dragged down. The arrow needs to be the last arrow. I should be able to drag that down a load until we get the last cell, which currently is in RC format, so let's just change it back so we can say RC converter. I use that for lots of things, so the converter will do things all different ways around, and then I say equals this, so that's the last cell we're in, and 61. We have an error on 63, and that's because we're going into an empty space. So I'm going to say if error, give me just a load of zeros there. So if error, give me 0, 0, 0, 0, like so, and then let's just drag that up. There we go, and we should be fixed. Okay, level 5, we have a more general case of this. We have given a row or column, and we're going to move all the way down it or across it. So let's do example 5. It's going to go from 81. Okay, so let's pull our starting address out. So it's going to be if this equals a column, then our starting address is basically going to be whatever this letter is and a 2, because we always start in row 2. And if it's not that case, we're in a row. So the row is going to be B and whatever this number is. So that gives us our starting address, and then our arrow is going to be if this equals column, give me the down arrow, otherwise give me the up arrow. Sorry, the right arrow. So that should give us our list of places to go. Now at this point we don't care if things are connected, we just want to figure out the kind of longest connection possible. So where we go to, I need to RC ref that as well, so it's just RC ref convert that. So that looks good. So I don't care about this if condition now, I'm just going to take the next location always. So let's drag that down, and then let's keep going until we hit kind of the end. There's about 100 columns and rows in the map, so it looks like the end is always going to be about here. So I essentially just want to keep summing these up and find the maximum of them. So I'm going to say equals this, and I'm going to say equals if this equals 0, do 0, otherwise do 1 plus this. So that should give us kind of a running total of all of the connections. So if we just look at the pipes here, we can see 1, 2, 3, 4, 5 are connected, but we're only getting a 4 here until we hit a 0. This is because if it's connected to the next pipe. So we just need to find the max of this and plus 1 basically. So equals max of this plus 1. I get some errors, so let's check what's going on there. 81. It's because, yeah, at the start we don't have anything in B. So if there's an error there, we'll just say 0, 0 again. So if error, do that. And I need to put it in quotation marks so it's text. There we go, and that looks correct. And we'll actually do a bonus now because it's related to this question. So the bonus is saying the longest straight tunnel on the board game is 18 tiles long. What address is the topmost or leftmost cell? So it could be down or across. Since we're already going down, let's check that. So I'll delete this data table out, and basically I just want all of the letters that we could possibly go down. So I'm just going to quickly say address of cells of the game board, and let's just grab all of this stuff here. So let's 2-col that. And then I want to basically remove the numbers and data table on that thing there. So to remove the numbers, I can say reg extract from that, /d plus. So capital D there is going to remove all things that are not numbers, i.e. all letters. So it just gives me kind of all of the cell addresses without numbers on. Let's copy these as values, and then let's data table this on this AG here. And then let's check if we found our 18, and the max down here is 18. So that means we don't have to check the rows, we have found it on the column. We just need to find where it is now. So I have a biggest lambda, so biggest of those, return those. So it's I, so let's delete this out. We know it's going to be I here. And let's try and find 18. So 17 is going to be this one, 18. And we start in this I47 here. And we can actually look at the pipes and see the whole connection here, 18 long. So the answer is going to be I47. I47. Okay, and then question 6, we're going to continue with our model. So we basically just change the arrow now wherever we run into a wall, but we follow basically question 4. So let's do example 6. Let's look up example 6 in here. Give me this stuff. So let's delete this out. Now, our address is going to be rcrefconvert of this. And our arrow is going to be this one, but we need to be able to change the arrow. So we're actually going to do an index. So let's say index. We're always going to start with 1, and then for arrow, I'm going to say index this on our arrow. And let's just lock that. Now, are we connected at the start? No, we're not. We don't need this anymore, so just delete that. So we're going to say if, when connected, then we're just going to take the original index, otherwise we're going to take the index plus 1. And then we should be able to drag this arrow index down and this down. And we also need to change our address from the last question. So now it's going to be, again, if we're connected, then it's going to be the address we went to, otherwise it's going to be where we came from before. So let's drag that down. And the question basically says we end if we land in a resource cell or we can't go any further. So let's check where the game ends. So say end. I want to say if exists the item we're going to in these tiles here, then give me 1, otherwise give me 0 for now. So we will see an end here, and instead of the 1, let's actually take the cell at the end that the item is in. So we get the cell address. The other end can be if there's nowhere else to go. So basically if the index is past 11, or we have an error like this, then it's the end. So let's just do it in here so we can see it spill out from this. So I'm going to say otherwise if is error this, then we're stuck at our original cell here. So let's just put some brackets in here properly. See if I write that. Otherwise 0. So there we go. We get 2 kind of endpoints on this game. Let's go there. And then let's just flag where we need to look for. So I'm going to say if this, give me 1, otherwise give me 0. And that just means because these are numbers, I can quickly pull out the first one. So I can then say x lookup 1 in here, give me here. And I want to convert that back to an address. So RC convert of that. So CX92 matches the example. Let's put the questions in. And hopefully those are the right answers. Yep. Question 7 is basically, you know, we are given the start cell is always B2, and how long does it take us to get to these targets when we can only walk through connected pipes. So for anything like this, I like to use my kind of mega maze lambda. Without it, I guess you would have to kind of do a circular reference method to check if the pipes are connected. If they are, add 1 with minimum distance and so on. But I think that's kind of messy. So I'm just going to set it up with my maze lambda. So my maze lambda, basically, I don't want to be able to walk on these cells. Whoops. I don't want to be able to walk on these cells, the headers or rows. And then I just want to replace anything that's there with a 1. Now, yeah, my maze lambda only works when there's a number in the designated cell. Normally that number is the distance it takes to walk through the cell, but any number works if I want to use something else as my distance calculation. The reason I have a number in all the cells as well is because I can turn things off. So if I was to delete an area like that, it means they're unwalkable cells. So it allows me to like block the map with, you know, things where there's objects you're not supposed to pass. But these are my walkable cells, and we can kind of start to set it up now. So I'm going to set something up on here. So I want to get all the combinations of pipes we can go from and to, so I can calculate whether they're connected. So I want to do the combinations of this. I want to take 2 of them, and I want to allow repetitions. So that's all of my possible pipes. Then I want to check if they're connected. So we've got top, left, bottom, and right. And then I want to do x lookup this pipe in here, return here. And I want to split it down into its digits. So split text of that. And then I want to do times the same thing, but on the from pipes. So times that, and we want from, and I want that pipe to be there. So that will give me kind of where it's connected. I'm just going to 2-row it so it's in the right place. And it's neaten this up a little bit. So if I spill that down, what you'll see is these 2 pipes can connect left or right, going from here to here. Going from this pipe into this pipe, nothing connects. Going from this pipe into this pipe, it will only work kind of left, and so on and so on. So I'm just going to set this up in my maze lambda now to pull these out as kind of the distances that it takes to go through each pipe. That might not make much sense, but I've got a whole video on this maze lambda, so if you watch that it might make more sense. To look them up a bit quicker, I'm just going to concatenate that. And then I'm going to say, so I need to push out my directions here because I need to define what directions you can walk in as well as what the distances are. So an RC ref convert, arrow converter, what's it called? Arrows lookup of this stuff. And so yeah, I'll call top up and bottom down. So all this lambda does is basically convert these to arrows, that's my arrow lookup, and then gives me the RC references, so that's where I can go. So these are my allowed moves on the map, and then I want to spill the distances between pipes there. Okay, so let's set this maze lambda up. First off, I don't want these ones we can't traverse to say 0, because it's not a 0 distance, and my maze lambda would take that into account. It's going to be unwalkable. So I'm just going to copy those as values, and then change the 0s to x's here. And what that will do is when I look up the distance, if it's not walkable, it just won't walk there, basically. So let's set this up then. So maze distance. Our map is the one with numbers in, because that's going to designate the walkable cells. I always have to have the map with numbers in first. And then I'm going to have my start is going to be B2. And then my targets are going to be in the question here. and I'm going to say my custom directions are these ones up here, and I'm going to use this maze lambda. So what we want to do is say let's cell from be address to contents of from in the map. Cell 2 is address to contents of 2 in the map, and this is going to be like just give me the pipes. So what I want to do is I want to kind of concatenate them so I can look them up in this distance table. So because I need to keep it as a grid, I need to say map cell from cell 2 concat. I need to call that something. Let's call it PC for pipe connections is that, and then we should be able to pull out our distances. So we can just say index this table for Xmatch pipe connections in this, and then we want to pull out the columns in order 1, 2, 3, 4. So that pulls basically the directions, well, the distances from this in order 1, 2, 3, 4, because all my pipes are going to be different. That's not going to make much sense unless you've seen my maze lambda video, but that will whir around for a bit and just give us all the calculations. One more thing I need to do actually is +1, because the start cell B2 counts as 1 for the movement. So this should be our answers for that question. And yeah, it's a tricky one, and it requires a lot of setup. I'm curious to see how other people solve this, but I mean, that's how I would do it. And then we should be able to do all of the bonuses now. So let's actually spill the full map. So I'm going to take this formula here, and I am going to put it in a new map here. So let's do that. Oh, let's take our targets away. That's what I've got to do. I want to take the targets away so the full map spills. To be fair, it's kind of quick still, even though there's a lot of calculation going on underneath this. So the ones with value errors are things we cannot reach. So let's just figure out, so the edges obviously don't matter, but these internal ones do. So I'm going to say equals sum of minus minus is error. So I want all of that. So that's going to tell me how many unwalkable cells there are. So there's 38 that I can't get to. That's this one, 38. And then what is the coin value of all resources he can reach? So on this map, I basically need to add in the distance of going to the actual kind of treasures. But if I'm in those cells, I don't want to be able to walk into the other ones. So let's just quickly add that to the maze lambda. So for this distances, I'm going to first say if exists, and then what's in the cell. So cell 2, if exists cell 2 in these tiles, then it's 1, otherwise it's that index stuff. But I also want to make sure I'm not going from one of those cells. Exists cell from in there times, let's just put some brackets in here so this works properly, times, and then not exists cell from in these tiles. So if both of those things are true, it's going to be a 1, otherwise it's going to be what we had before. And then if that works, we should see at the bottom, we can actually now go into these cells where the things are, the treasures are. So now we want the coin value for all of the treasures we can reach. So I'm going to say if error, all of this stuff again, then give me 0. Otherwise, X look up what's in the actual map in our tiles and return the value. If it's not there, give me 0. And I should be able to sum most of that stuff. So if someone say if is error, that stuff, give me 0. Otherwise, X look up the map on the tiles, blah blah blah. That should be fine. And then sum that up. So that should be the answer. And then Vlookie wants to take all the resource he can reach in the mine. He can only carry one resource back at a time to the entrance. How many cells will he need to travel in total? So we basically just need to find all of the resources and find the travel time to them. So I can say find in map all of these treasures in my map. So that takes an array. So this is give me all of the locations that those treasures are in. So I want to say address the contents of that stuff in this sheet here. So that's my distances to everything. And let's make sure I put a bracket on it. So this is all of my distances from before. Where it's an error, I want 0 because that's the unreachable treasures basically. So if error 0, and I want to sum that up and times it by 2 because we need to go there and back for all of these. So sum of that times 2, this should be the answer to the final bonus. Yeah, for me this was a really hard case. I think there must be a more efficient and simpler way to do it. So I'm looking forward to seeing other people's solution videos. But I mean, this is what I came up with when I was going through it sort of second, third time. I guess at the end my maze lambda helped a fair bit. I know other people have like network kind of lambdas now where they list all the cells and all their possible connections. So maybe you could do it like that. But yeah, anything circular referencey, my maze lambda should be able to do in theory. But yeah, real tricky case. Anyway, hope you enjoyed. See you next time.